With decades of experience in the construction industry, Williams is a leader in forming hardware, post-tensioning, and rock bolting products for large projects such as dams, tunnels, power plants, bridges, and water treatment plants. Williams has manufactured rock anchor systems for over 40 years and has generated more anchoring products and techniques than offered by a single manufacturer anywhere else in the world. Most popular for solid rock formations is our Spin-Lock anchor system. This mechanical anchor can be used in both hard rock and concrete applications. The Spin-Lock anchor is available in bolt diameters from 1/2 inch to 2 inches, in ultimate strengths from 18 to 360 kips, and in a variety of bolt steel types and different sized head assemblies to meet the wide variety of load conditions and anchoring medium. These Williams manuals provide technical data and installation instructions for our Spin-Lock anchors. Williams representatives have vast field experience that can save money and time during the initial design phase. This video was prepared to show a detailed procedure for installation. Remember, when on any construction job site, use common sense and the proper safety equipment. The first step in Spin-Lock installation is preparing a drill hole. The hole for a Spin-Lock anchor can be core drilled or drilled with various types of handheld or mobile rotary impact drilling equipment. Drill hole diameters are provided in the Williams manuals and are related to the size of the anchor head. It's important to drill the hole deeper than the actual embedment depth of the anchor for two reasons. First, to allow for larger rock fragments that can drop to the bottom of the hole, and second, to assure grout coverage at the back of the anchor. In overhead bolting, 1 to 3 inches of overdrill is sufficient because most rock debris will fall out of the hole. For shallow embedments in concrete, it is only necessary to drill 2 to 3 inches beyond the anchor embedment depth. In long-length rock downbolting, the hole depth should be overdrilled 10 to 16 inches beyond the embedment of the anchor. For very long anchorages, it can sometimes be advantageous to use a larger than specified diameter drill in approximately the first 3/4 of the hole to ease anchor insertion. If you have any questions regarding drill hole requirements for the Spin-Lock anchor, contact your nearest Williams field representative. Holes should be checked to make sure they are clear. This can be done with a simple probe. If necessary, the drill hole can be flushed with air or water to remove debris. The bearing surface for the plate at the top of the hole should be made relatively flat. Remove any rock points that could end up under the plate. Before inserting the anchor into the hole, it should be inspected and the anchor readied for installation. The anchors are provided completely assembled from the factory. The thrust ring is threaded fully onto the bolt rod, and the cone and shell are lined up as shown and snug against the thrust ring. For best performance, the Spin-Lock anchor should have a close tolerance in the hole. If the anchor is too loose, it can be expanded slightly by migrating the cone into the shell to slightly expand the shell. If the anchor is too tight in the hole, the cone can be backed off by rotating it. Then the shell can be tapped closed. Occasionally, if the drill holes are obstructed, it may be necessary to tap the Spin-Lock into the hole. Use the setting tool or a double nut to protect the outer threads from any damage from the hammer. At this time, the height of the protruding bolt can be adjusted. The torquing procedure required to set the Spin-Lock anchor minimizes the movement of the bolt out of the hole when it is tensioned. Be sure that there is an adequate amount of thread under the plate for final adjustment. The anchor head is set by applying a torque to the anchor bolt. The torque values required to set the anchors are dependent on the size and type of the Spin-Lock and are given in the charts in the Williams manuals. The setting tool allows the installer to torque the bolt without damaging the outer threads. The two-part tool design makes it easier to attach and remove the tool. Tooling for galvanized bolts must be ordered oversized to allow for the zinc coating. Be sure that the threads in the tool are well greased before using. The tool is attached to the spin lock by threading the assembled tool completely onto the anchor until it is fully engaged. The setting tool should not be in contact with the nut or plate. The long-fitting tool adapter is fitted over the setting tool, and an impact wrench is used to torque the bolt rod. The impact tool supplies a very quick, sharp force that allows the anchor to start opening as it encounters friction in the hole. The rotation should be in a clockwise direction. Care should be taken not to spin the anchor backwards. After the initial setting is complete with the impact wrench, a torque wrench should be used to assure that the proper torque has been applied to the bolt. A torque multiplier can be used when the required torque value exceeds the maximum torque rating of the wrench. Very high and accurate torque values can also be attained by the use of the Williams pneumatic torque wrench. The pneumatic torque wrench consists of the wrench body and a control unit that is adjusted in the field to the torque required. Although the operation of the pneumatic wrench is very simple, the instructions that are provided with the wrench should be fully understood before operating this device. After the spin lock has been set, the setting tool can be removed by loosening the top bolt while holding the body of the tool with a wrench to prevent the bolt from spinning backwards. You can then unthread the whole setting tool from the bolt. Use Williams Will Quickset as needed to seal or level the drill hole entrance and prevent grout leakage. Mix Quickset to a paste firm enough to form into a ball and press it into the drill hole around the bolt and tubes prior to setting the plate. Will Quickset will initially set up in 10 to 20 minutes. The next step in installing the spin lock anchor is testing and pre-stressing the bolt. Williams recommends pre-stressing and/or pre-testing the anchor for the following reasons. Every bolt is pre-tested as part of the normal installation prior to being put into service. There is full-length elongation prior to grouting. The grout hardens and locks in around the elongated bolt so that there will be negligible stress relief of the anchor and surrounding rock. Pre-stressing to or above the design load will eliminate any uplift of the nut due to a tension load on the anchor. Lack of uplift will minimize any fatiguing of the bolt due to cyclic loading that would otherwise stretch and relax the steel bolt rod. And because the elongated bolt is grouted, this eliminates any spalling of grout at the surface that could lead to exposure to the environment and possible corrosion problems. The simplest method of putting tension on the bolt is by torquing the nut against a plate to take advantage of a torque-tension relationship. The charts in the Williams manuals show the torque required to put the bolt in 50% of ultimate tension load. A graph relating torque to tension for different bolt rods at different loadings is given in the Williams manuals. These values are based on using nuts with washers on clean, dry threads with no lubrication. To torque tension the bolt, install the long-fitting tool adapter directly onto the nut and torque using the hand or pneumatic torque wrench until the desired torque value is reached. The most accurate method of tensioning spin lock anchor bolts is to use a direct reading method of pre-stressing, using a hydraulic jack to put the bolt in tension. The Williams calibrated hydraulic test jack assembly consists of the jack frame, the ram, the test rod assembly, hydraulic hoses, the PSI gauge, and the pump. The hydraulic jack is attached to the bolt by setting the frame over the plate so that the bolt is in the center, attaching the test rod to the bolt with the test coupler, and threading the nut to the plate at the top of the jack. Be certain the jack will not bend the bolt during loading. A chart is provided with the jack that references the PSI directly read on the jack gauge to the tension load actually applied to the anchor. In production bolting, merely pump the hydraulic jack directly to the pressure corresponding to the working load. If specified by the engineer, the spin lock anchor can be load tested as high as the published yield of the bolt rod prior to reducing and locking in the design working load. This is done by jacking the bolt to the pressure corresponding to the specified test load. Remember, The test load should never exceed the published yield. When the anchor has passed the tension test, reverse the valve at the pump and drop to the pressure that corresponds to the reduced working load that will be locked off on the bolt. With the hydraulic jack maintaining the working load on the anchor, lock off the load by tightening the nut until a slight drop is noticed on the pressure gauge. Release the pressure on the hydraulic jack and disconnect the jack from the bolt by unthreading the coupler. The Spin-Lock anchor has now been pre-stressed. The final step in installing a permanent Spin-Lock anchor is to grout the bolt. Grouting locks in the pre-stress in the anchor and provides corrosion protection. Although the mechanical head of the anchor holds the full strength of the bolt rod, the grout will provide an additional safety factor as well. In many cases, the grout bond factor would be capable of holding the full design load even without the expansion anchor. Grouting is accomplished by pumping grout from the lowest gravitational point on the anchor. When down bolting, the grout is introduced into the drill hole on the anchor end and fills the drill hole. When up bolting, the grout is introduced at the nut end of the bolt and is pumped up to the anchor end. You cannot ensure the complete encapsulation of the bolt if the grout is merely poured from the top of the hole. The recommended grout is Willex cement grout. Willex is a type of Portland cement grout that's chemically compensated for shrinkage. This grout conforms to ASTM C845. No sand or aggregate is used with this grout when pumping it into the drill hole. Willex is available in moisture-proof, resealable 5-gallon plastic pails. The powdered grout is mixed with water to a pancake batter consistency. This requires a ratio of approximately 2.5 to 3¼ gallons of water for each 5-gallon pail of powdered grout. The mixed grout should be passed through a screen prior to pumping to remove any lumps of unmixed grout that could clog the pump. The grout can be pumped into the hole using either a hand pail pump or an air-driven pump. The grout is introduced to the lowest point in the hole either through tubing along the side of the bolt or through the hollow core of the patented hollow core Spin-Lock anchor. This hollow core acts as a grout conduit that will assure that the grout is always introduced from the lowest point in the drill hole. In down bolting, the grout is introduced beyond the anchor head and will assure that even the head of the anchor will be encased in grout, unlike a tube system that could bend or pinch and can never be placed beyond the anchor head. In up bolting, the grout is pumped in from the nut end of the bolt through a short piece of grout tube, and the hollow core acts as a de-air tube to release air pressure from the top of the anchor. The grout will displace water and debris as it fills the hole. A steady stream of grout means a thoroughly grouted anchor hole, including seams and cracks in the rock or concrete. If grouting is going to be suspended for more than a minute, the grout pump should be flushed with clean water immediately after use. Holes in bad, seamy rock sometimes fail to return cement grout, no matter how much is pumped in. Williams Polygrout is a very fast-setting, two-component polymer grout that is not sensitive to wet conditions. Polygrout is designed to fill seamy rock holes. It effectively displaces water and will remain in the hole until it's fully cured. The two components of Williams Polygrout are supplied in 55-gallon drums that are mixed as it is pumped through a mixing wand. The grout goes directly from the wand under pressure to the drill hole, since setting times are so fast. As you can see, Polygrout will set even as it runs down a vertical face. For more information regarding the use of Williams Polygrout, contact your nearest Williams representative. Williams has available to the contractor a complete line of power-activated or hand-operated rental equipment for a speedy installation. Now that they have been set, tensioned, and grouted, the installation of the Spin-Lock anchors is complete, and they're ready for a long service life. The Spin-Lock anchor is just one of many products developed by Williams. Whether anchoring in hard rock or concrete, weak rock or soils, Williams has the experience and the technology to help you meet your anchoring challenges.